Hello everyone. Here we're going to be talking about a non-clearing market in an Edgeworth box. Now when we're doing this, we're moving towards a model of a general competitive equilibrium. So in order to get there, we're going to set up some steps. The first thing is we're going to remind ourselves of what an Edgeworth box is, what it looks like. We're then going to be talking about price offer curves. We're then going to see how we'd get a non-clearing market at a certain price. And that's what this little video is about. The next video is going to be about a clearing market at a given price and how that clearing market is going to be a Pareto efficient outcome in a generally competitive model. Okay, so let's first remind ourselves of some things. We're going to have two people. We've got Adamo and we've got Beatriz. These are like Ayanda and Biko, who we had in previous chapters. Now, we've got these two people, and we see that A is down here in this corner, and B is up here in this corner. Now remember that B gets data going down from the top corner and gets coffee kilograms in terms of going from right to left at his origin. Now for A, it's the opposite. We've got A getting more coffee going from left to right, and then getting more going from bottom to top of the data in terms of his Y. Okay, so those are the things that we can think about. And we think that the total amount of the two goods available, here the data and the coffee, those are measured by the dimensions of the box. So Adamo has a lot of coffee and Beatriz has a lot of data. So if you look down here at point Z, that's their endowment point. And we can see that point as indicating that Adamo has a lot of coffee, not much data. And on the opposing side, Beatriz has lots of data and not much coffee. So these endowments are the fallback options for the two traders, as they are the outcomes that they will experience if they do not trade with each other. So if neither Adamo nor Beatriz trades with the other person, then they're just going to stick at their endowment point. So when we think about that, what does this mean? It means that the participation constraints of the two are the indifference curves through point Z. So if we take point Z or point Z and we take each of their indifference curves, so for Adamo, it's this indifference curve through point Z, and for Beatriz, it's this indifference curve through point Z or point Z. We can see there that those indifference curves are their participation constraints. They are the utilities that they receive at their endowment. So we show the allocation resulting from a trade that each values as much as not trading at all. So at any allocation along those participation constraints, we can see trades that they would value as much as their initial allocation or their endowment. So the set of allocations that are Pareto superior to their endowments at Z are shown by the Pareto improving lens. So this yellow lens, which is encompassed by those two participation constraints, those are all the allocations that are Pareto improvements over point Z. So the Pareto improving lens narrows down the set of possible trades that Adamo and Beatriz might make. So the question we can then ask ourselves is, why will points not in the Pareto improving lens occur? Okay, and so, or why will they not occur? So when we're thinking about this, we're wondering about a point like this over here, which I'm going to call point K, or a point like this, which I'm going to call point J. So point J, what is that? That is below Beatriz's participation constraint. She would not voluntarily agree to be at point J. So she's not going to choose to drop her coffee and data to such a low point because it takes her below the utility she would receive at her participation constraint. Similarly, for Adamo, point K, that would also be a point below his participation constraint. So the corresponding indifference curve, if we were to draw it, would be lower than his participation constraint. That would be a lower utility for him. As a result, he would not voluntarily choose to adopt that trade. So that is why neither of them is going to choose a point outside of their participation constraints. They're only going to choose trades that are within the Pareto improving lens. Okay, now every point in the Pareto improving lens is an allocation that both A and B could agree to if the only alternative was no trade at all. So to understand these trades that each might make, we're going to have to consider the prices that they could be offered. So to do this, we're going to use the price offer curve. So you might recall that we looked at price offer curves previously in chapter 4, but just to remind you, how do we construct them? What we have to do is we have to hypothesize a different set of prices or a set of different prices. So what we can see here is that we've got three different prices, those prices have to go through the original allocation. Now we indicate a price as a relative rate of exchange of the one good for the other good. They're saying how much of, say, the Y good, the gigabytes of data, you'd be willing to sacrifice in order to get an extra unit of the X good. Or vice versa, how many units of the X good you're willing to sacrifice in order to get more units of the Y good. So depending on the slope of these lines, we will then have different prices. So what we can see here is that we can construct a price offer curve by positing a set of different prices, then finding the utility maximizing allocation that would be chosen by the person for that price. And how do we find that? We find that by setting MRS equal to MRT. So notice what is happening here. The price line is giving us a marginal rate of transformation. The indifference curve gives us a marginal rate of substitution. At each of the points, K, J, and N, we're finding a point at which MRS equals MRT for Adamo. He sets his indifference curve tangent to the constraint, or he's choosing the indifference curve that would be tangent to the constraint, the price, and at that point he would be maximizing his utility. For each of those utility maximizing points, when we map them out, that gives us the price offer curve for every single price that he has going through point Z, his endowment. That then gives us Adamo's price offer curve. Okay, so what have we done there? We've treated the price as a constraint on utility maximization, giving us an MRT. We then get the MRS from our indifference curve, where MRS equals MRT. We find a utility maximizing point, or a constrained utility maximizing point. If we do that for all of the potential prices that Adamo might be offered by Beatrice, that gives us the price offer curve. In that way, Adamo's price offer curve is like his best response function to each potential price that Beatrice might offer him in exchange for goods that she has. Okay, so what we see here for three price lines, PK, PJ, and PN, we think of these as alternative budget constraints that Adamo might confront. And then we have a point of tangency with each potential indifference curve that he would have, and those occur at points N, J, and K. Those altogether give us his price offer curve, or his best response function. All right, let's put these together now. What we're going to do here is we can see that we have a price offer curve for Adamo. We've just found that over here, the same way that we constructed it previously. And then we do the same thing for Beatrice. Beatrice has a price offer curve that would have been constructed in exactly the same way that we just constructed Adamo's price offer curve. So what we're going to see here is that we've got a price line PJ. So this price line PJ is telling us some price at which each of them is willing to exchange. Now, when we look at this price, in order to understand each person's best response to this price, we have to find the point at which that price intersects their best response functional price offer curve. So let's find those points. We can see that it is at point J for Adamo, and it is at point H for Beatrice. Now, the first thing to note is that these are not the same point. We're not finding a point of intersection with the price offer curve for the price for both of them. Okay, so this is going to lead us to have to think about the fact that this is going to be a non-clearing market at this price. What do I mean by a non-clearing market? It's a market at which the quantity demanded does not equal the quantity supplied of the goods. That's what it means when we have a non-clearing market. Okay, so to think about that, what are some questions that we could ask? Given Adamo's price offer curve, how much coffee does Adamo want to sell at the price PJ? Given Beatrice's price offer curve, how much coffee does Beatrice want to purchase at the price PJ? And also, does the market clear at the price PJ? So I've already told you that it's not going to clear. We're just going to have to see exactly why it doesn't clear at that price. So here's the thing to think about. If we compare the allocation at point Z or point Z, and we see for Adamo on his price offer curve, how much of the good X is he willing to trade to Beatrice at that price? What we can do is we can see here that we have a quantity of coffee that Adamo is willing to trade to Beatrice at that price. So we can see that as the different horizontal quantity between Z and J. Okay, that's telling us how much of the quantity X Adamo is willing to sell to Beatrice at that price PJ. Now, in response, what would he expect? He's expecting some amount of Y to be sold to him, traded to him by Beatrice in exchange for his good X. And we can see that as the vertical distance between the 2 points. Now, that's all well and good, but notice the difference here. That's all for him on his price offer curve. But then we have for Beatrice this point over here, point H. Now notice that there is this additional horizontal distance, which we're just going to measure over here and going upwards, between what Beatrice would actually like to buy of X at that price. So Adamo is willing to sell the difference between XJ, J, and Z in terms of what he is willing to sell at that price. But the thing is that Beatrice would like to buy more X at that price. So the quantity demanded is greater than the quantity supplied. Okay, so Adamo is only willing to supply a certain amount. Beatrice, in fact, wants more of it. If we're looking at the vertical axis as well, we can see that for the original trade, in terms of how much of the quantity of data Adamo wants, Adamo only wants this small amount of data shown by the vertical distance here. Whereas at that price, what can we see? How much would she in fact want to sell, Beatrice? Beatrice would in fact like to sell more in exchange for more X. So, what does this tell us? At the price PJ, Adamo is on the short side of a non-clearing market. Beatrice is on the long side. So remember, we had these ideas of the short side and the long side of the market. The short side of the market is the side of the market on which the number of desired transactions is least. The long side of the market is the side of the market on which the number of desired transactions is most. So as we've seen in previous chapters, the transaction that will occur is determined by the amount of trade the short side person wants. So because Adamo is on the short side, he wants to sell less of the X good and buy less of the Y good than Beatrice is willing to sell of the Y good and actually demands of the X good. So this is because the exchange is voluntary. Beatrice cannot force Adamo to trade with him. To trade with her. And so as a result, what we want to think about here is that is J a Nash equilibrium, this point over here? J is not going to be a Nash equilibrium. We're going to be able to see that the two of them could in fact deviate and do better. The question is, how could they deviate? The way in which they deviate is by thinking about alternative prices where they would both do better than point J. Some of those alternative prices are shown in this potential Pareto improving lens here, the thing that I'm scratching over there, which is in yellow. Those are alternative Pareto improvements over point J, suggesting to us that they could find a different price to PJ that would be better for both of them. So that point PJ is not Pareto efficient, and it's also not a Nash equilibrium. Now what we're going to be doing in the next video is thinking about what the trades are that are Pareto efficient and which are ones that clear the market.